tutorial where I'll show you how to create a visualization for one of the most popular algorithms in computer science. I really think you're going to learn a lot in this tutorial, and not only will it be a great resume booster, but it's going to be great for your personal knowledge as well. So let's get started. Now I'll give a brief demo so you guys know what's going on here. Basically, my mouse is being tracked, or the canvas knows the position of my mouse on it, and the shortest path is being determined live while I move around. Now if I were to click on one of these hexagons, it reorients, and this is all finding the shortest path using the breadth first search algorithm. As you see, the arrows are pointing out in a breadth first search fashion, and we are finding the shortest path wherever we move the mouse. Now we need to open up our Windows PowerShell to check our version of Node. Make sure it's greater than 6. So we type node v. We're at version 10. And we also need to check that our npm version is above 5.2. So we type npm v. Okay, now that we're all set, all we need to do is type npx create React app, and we will call this BFS visualized, and we hit enter. We'll give this a moment to create and move right on. Okay, now that our project is all loaded up, let's go into it and type cd BFS visualized. And all we have to do here is type npm start. And we should get a window popping up here. And we see our React app right here. Now let's go into the folder that it's in, inside of our C. Just navigate over to wherever you've saved it. Open up your favorite text editor, in this case it's Atom for me, and we will move it over there. Okay, once it's dragged over here, we can go inside of the source file, and we're going to create 2 folders. We'll create BFS, or actually we'll only create BFS for now. So let's go in here and create some new files. We'll say bfs.jsx, and then we also need to create bfs.css, where we will do the styling. Okay, so now that this is done, let's go into our app.js. And we need to import our BFS class, our bfs.jsx. So to do that, we type import BFS from BFS. And with a semicolon, and we're all set. Now we can also erase all of this, because inside of here we will put our module BFS, and we can hit Control S. Now let's go over to our BFS class, and inside of here we will write the following code. Okay, after hitting Control S, we are done with this class. So basically what we did here is we are importing app.css, and actually we'll change this to BFS because we're going to use that file to style our canvas. We're also importing the React components that we need. We're creating our constructor for our class BFS, and inside of the render function, which will display things on the page for us, we created a div with the class name BFS as well as a canvas. Now let's go into bfs.css and give this a little styling. Okay, now let's hit Control S, save this, and let's go to our screen and see if it works. Parsing error, unexpected token. Looks like we typed export instead of export, so back to our bfs.jsx. And there we go, let's hit Control S. BFS CSS. Oh, okay. So let's go back over to Atom. And we have bfs.css. It looks like we are simply missing this period. And there we go. We have our canvas, but it's over to the center. We're going to have it over to the side there. So let's go into our app.js and remove this line of code. And we're all set. There's the canvas where we need it. Okay, so on to the next part, which is to simply go to our bfs.jsx class, and we're going to add a component will mount function. Okay, so our component will mount method is always a good place to initialize our app. However, we won't see the stats that we created here because that is going to be left to our component did mount method to display. But first we need to create a reference to our canvas so we can actually display the stats in component will mount. Okay, so this is our reference to our canvas, and we can use it by saying this.canvas hex. So let's create our component did mount method and show that our canvas width and canvas height have been changed. Okay, now that we've created our size of our canvas, we need to start creating our hexagons. And to do that, we have to go over to Google Chrome and visit our hexagonal grid website. Now, this is a website that's going to help us a lot throughout the process of making this app, and we need to calculate the coordinates of each corner of the hexagon. So let's copy this function here. Go back to Atom and we will paste it. So what we're going to change about this is just a few things to clean this up. Okay, so we can hit Control S there, and basically, like I said before, this function, it just gets the coordinates of the hexagon's corners. Then we can return that as a point, and with those points we can draw a line between them, thus creating our hexagon. So let's define this point function here, and notice I took out the size variable, I changed it to this.state.hexSize, and we added math in front of our functions here. So let's create the point function. Okay, so this is our point function, and now we need to draw our hexagon by drawing lines in between each of the points that are returned. So let's make the DrawHex function. Okay, so right here in our DrawHex method, we are simply drawing a line between the starting x and y points and the ending x and y point. Now let's make this draw line function so we can get this hexagon created. Okay, now that we have our draw line function done, basically we're just drawing a line from our starting x and y to our ending x and y. And let's quickly go over and check our corner chord method, because this needs to be changed to a plus sign here. And let's also go up here and define hex size, because we have not done that yet. So let's go into the constructor and simply write this line of code, this.state. And inside of here, we are going to assign our hex size to 20. Okay, let's hit Control S on this and check and see if it works. Oh, and that's because we need to simply put a colon here. We'll say save. And we see we have our hexagon drawn. So now we need to draw a bunch of hexagons to cover our whole board, and for that we will create a DrawHexes function. So let's open up Atom and create this DrawHexes function. Okay, so here we've created our columns and rows for our hexes. Now what we have to do is go up to our component did mount method, and we'll get rid of this and call our DrawHexes function. So we'll hit Control S. Oops, I accidentally opened up IntelliJ. But what we have here is a blank slate, but let's go to inspect and go to the console. and we see that we have our rows and columns, but now we need to convert them to coordinates of our hexagons on the canvas. So to do this, we need the x and y coordinates of the center of each hexagon, and we will use the function inside of here in order to get that. So we are looking for Hexa Pixel. X2 pixel. Okay, so we will copy this and place it into our code. Let me just close this IntelliJ. Sorry about this. Okay, so we copy this function, and back to our atom, we will paste it underneath our DrawHexes function. Now we have to change a few things in here. So what we did here in this hexapixel function is change our argument from hex to h. We changed our var to let here and use the math.square root function. We make sure to change hex to h right here, and finally we're returning this dot point. So now to use this function, we go into our DrawHexes method and we'll type this following code. Okay, so what we did here is just essentially assign our center so we can actually print this out and see the coordinates of the center of each hexagon based on their row and column. Now let's also create this hex function here, which will return us an object. Okay, so after this is done, we can go ahead and hit Control S and go to our screen. And it looks like we have exactly what we wanted. So say that our hexagon is at it's in row 1, column 3. The coordinates of its center will be 86 and 30. So this way we're finding the center of each of our hexagons. Now let's move on to the next part. Okay, and before we move on, let's actually draw the hexes on the screen so we see what we're dealing with. Now we're just going to come right under here and we're going to say, okay, so this line of code will draw our hexagon on the canvas. Let's say Control S. And it looks like we are missing this R here. Save that. And we see we have our hexagons on the screen. So now the next order of business is we need to draw the specific column and row of each hexagon onto this grid here. So to do that, we are going to create a new function and call this DrawHexCoordinates. Okay, so here for each of our hexes, we are drawing our our column and our row. And where are we drawing it? Well, it's going to be a pixel deviation from the center value. So inside of our pixel, we're saying the center and getting the x value, and we're saying to the left 10 pixels, and for our row, we're going to display it to the right 10 pixels. So we are also placing in the middle of the hexagon. Now let's hit Control S. And we also need to add a few more things, which is this DrawHexCoordinates inside of our DrawHexes method right here. Okay, let's hit Control Save and see how that looks. So now here we have our hexagons with the 0 and the 1 and for all of the rows. So we have what row and what column they're in. Now let's actually display our 0, 0 hexagon, which is up here in the corner. Let's display it near the middle of the screen. So we're going to go into our constructor and we will type the following. Okay, let's see how this looks. And that's because we actually have to add this line of code down here to Hexa Pixel. Okay, so over here we're going to add the origin. And we're also going to add it onto the end here and say xorigin.x. And we will add hexorigin.y right here. So now let's hit save and check our app, and it looks like we have moved it close to the center here. So we can actually just adjust our X a little bit. We'll save that, and we moved it over to the right a little bit more. Okay, so now let's notice that the hexagons are only being drawn to the right and to the bottom. So look here in Atom, if we change this value and draw hexes right here, or I'm sorry, draw hexes, and we'll start it at -4. So we're starting it 4 rows back and 4 columns up. Let's save that. And we see that it's drawn a lot more hexagons for us. So let's actually create and fill the entire board with hexagons. So to do that, we need to find out the hexagon's width and height so we can draw as many hexagons as we need to fill the entire canvas width and height. So let's go and create a function called getHexParameters, and this function is essentially going to get us the height and width of each hexagon as well as the vertical distance and horizontal distance between the hexagons in each row. Now this function was grabbed from the website, but I will actually skip copying and pasting just to save some time. So here we go. Okay, again, you can see this function on the website, but essentially it's just going to get us the hexagon width and height and the distance between, or the horizontal distance and vertical distance between the hexagons in each row. Okay, so now let's add some code over to our DrawHexes function so we can essentially establish how many hexagons we need on the left side of the origin, on the right, top, and bottom. Okay, so above our DrawHexes function, we are going to write this. Okay, so this function, or what we've added to it, just determines, like for example, this Q left side. This is going to determine how many hexes we need on the left side of our origin, on the right side, top side, and bottom side. Now I had to mess around with these numbers a little bit because it varies depending on the math that you use. Like I use this times 4 to essentially multiply this number times 4, so we have a greater number of hexagons. It ended up being times 2 here. Then we are going into our row and column creation, and this if statement here is making sure that we're only drawing hexes within the boundary of our canvas, and we're eliminating the others that are outside or any extra. So we can delete this console.log statement, go ahead and hit Control X on this, paste it in here, and we will hit Control S on this. Now let's go and check our canvas, and we see that nothing has changed, and that is because we are running actually a different app. So let's go into BFS visualized and npm start. Okay, and we have an error here, and that's because we did not define our hex parameters. So let's go into our component will mount method, and we will write this following code. Okay, we're all set. Now let's go back to our app, and we see that we have our hexes covering the grid. So this is looking really good right now. We have our origin at the middle, and we have our board covered. So let's move on to the next part of the app. So the next thing to do will be modifying the app so that wherever the origin is, or no matter where the origin is, that there will always be enough hexagons to fill the entire board. So just for an example, let's change these two values here to 30, 30. We'll hit Control S, go back to our board, and we see that we are lacking now hexagons on the lower left hand side of the board. So let's change that so no matter where the origin is, there will always be enough hexagons to fill the entire board. To do that, all we have to do is modify our DrawHexes function. In the meantime, we will change that back to 350, 300, and we'll go into our DrawHexes function and write some lines of code. Okay, so this is our new DrawHexes method, and what we wrote here looks like a lot of confusing code, but trust me, it's very simple. So I'm going to open up Paint here because the app is no longer the same since before I made all this code. So we know that our problem was that when we shifted the origin, our hexagons looked like this, with these rows shifted over to the right. So we made this p variable to determine our even rows. Now, if the row is even, we're incrementing p, and we're pushing over p, or we're pushing over the row as far as p. So like if we're at row 2, p will be 1. So we're moving over row 2, 1. If we're at row 4, p value will be 2. So at row 4, we're moving over 2 columns. And for row 6, we're moving over 3 columns, and so on. So in this way, no matter where the origin is, we will always have enough hexagons to cover the entire screen. Same goes with the top side down here. So this code is very simple, and we're just keeping track if we have an even row, and we're moving it over right here. So now that this is done, I think I'm going to end the video. This will be just a 2-video series, but let's take a look and see if it works really quick. We can go over here to X, make this 3030, hit Control S, and we look that we have a full nice hexagon board, although our origin is over here in the top left corner. So we're going to finish this in the next video, and stay tuned, guys. This is going to be a really nice resume project for you all, and I left the code down in the description. Don't forget to hit like and subscribe, and thank you very much for watching.